This video is going to discuss the basics of adding and subtracting fractions. It will make the assumption that the denominators are the same, and we will make the assumption that you have already learned how to reduce a fraction. Denominators must be the same in this process. We will add the numerators. We will put the sum, the addition, right, as a sum, of the numerators in step 2 over the original denominator. We will then reduce and or change the answer to a mixed number as needed. Let's visualize this process first. So let us look at these two fractions that we want to add together, and let's put them in terms of what they would numerically represent. In order to represent this as a fraction, we have to find out how many pieces it's broken down into. So there's 1, 2, 3, 4, 5, 6, 7, 8. So this represents 2/8. This one is 1, 2, 3, 4, 5, 6, 7, 8. So this one is 3/8. And so what we're asking when we add these two fractions is what portion of a single whole is being represented if we're going to take 2/8 and put it together with 3/8. Well, we can visually see that we would have 5 of these 8s, right? So what we're saying is that we have 5/8. And it wouldn't make very much sense if when we went to add things together, if this one was broken into bigger pieces, say. Maybe it was only broken here, 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 and here, and we had 4 of those shaded, or 3 of those shaded in or something. We wouldn't want to add them together with those because then it'd be like comparing apples and oranges, and that's why the denominators have to be the same when we add them together. Okay, so let's let you try these. So pause your computer, or pause the video, and see if you can add these two fractions together with that brief explanation from a visual standpoint. If you can't, don't worry about it. I'm going to go over it in just a few seconds. All right, I hope you actually paused your computer and that you tried this on your own. So we're going to add the numerators. Those are the 5 and the 3, and I'm going to put it over the denominator that's the same in both of them. So 5 plus 3 is 8. I've got to get it down to a single number. I can't just leave it as symbols. And then that's over 27. Now the last step here I'm not going to do because all these I'm just practicing the basics. Then we'll get into what happens with that step number 4 where you have to reduce or change to a mixed number. Now this next problem, when we do this one, again, we're going to take the numerators, 9 and 13, and we're going to add them together, and we'll put them over the denominator that's the same in both, 35. Then we go 9 and 13, which is 22, and that's over that common denominator of 35. Now if you on either of these instances added these two denominators, and so here you would have gotten a denominator of 54, here you would have gotten a denominator of 70. If you did that in either case, that would be wrong. Those would not be the denominators. When you're adding fractions or subtracting, you are not doing anything with the denominators. The only thing the denominators do is come along for the ride, and it has to have the same denominator. Make sure you realize that. What happens when the portion becomes an improper fraction? So when it becomes more than one whole thing. Let's take a look at that. So we're going to take a look at 7/13 plus 8/13. So we add the numerators, 7 plus 8, which gives me 15, and we carry along the common denominator, 13. See, the numerator is larger than the denominator. That means it's an improper fraction. So remember, to change an improper fraction into a mixed number, we divide the numerator by the denominator. 13 goes into 15 one time. 1 times 13 is 13. 15 minus 13 is 2. So we have a remainder of 2. Remember the whole number, the quotient is the whole number, 1. And our remainder, the 2, is the numerator of a new fraction. And the denominator is the same denominator it was before. So 1 2/13 is our final answer. What would happen if there is another simplified way of writing our answer? Now this part, like I said at the beginning of the video, if you have not studied how to reduce or simplify a fraction, this will not probably make a lot of sense, and you should go and listen to that video before trying to understand this one. So we first of all would add the numerators, 3 plus 1, which is 4. We will carry along the common denominator of 8. 4/8 is not a simplified fraction or a fraction that is in lowest terms. It has a common factor in 4 and 8. So what we want to do is we want to either use the least common denominator, greatest common factor, or prime factorization to simplify this. So once again, greatest common factor or prime factors to do it. So if I went with the greatest common factor, 8 is made of 1 and 8, or 2 and 4. And 4 is made of 1 and 4, or 2 and 2. And so the greatest common factor in these two would be the 4. So the greatest common factor method says that we're going to divide out that GCF, that greatest common factor, from both the numerator and the denominator. 4 divided by 4 is 1, 8 divided by 4 is 2, and there's our new answer in lowest terms. Now, the least common denominator method of doing that, or least common denominator, pardon me, the prime factorization method of doing that, the prime factorization method says I'm going to find the prime factors of 4. That's 2 times 2. And then the prime factors of 8, that is 2 times 4, but 4 is 2 times 2. So for 4/8, we would rewrite 4 as 2 times 2 over 2 times 2 times 2. That's 4 in the numerator and 8 in the denominator. And then we cancel. One of those 2's goes with one of the 2's in the denominator. One of the 2's in the numerator goes with one of the 2's in the denominator. And now when there's nothing left to cancel, we simply multiply straight across. 1 times 1 is 1. 1 times 1 times 2 is 2. And there we see the 1/2 again. So greatest common factor method here in yellow, prime factorization method in green. Either way, that's the simplified version of 4/8 and is the correct final answer. What happens if we had to do both of those? Let's look at an example where it's both improper and not in lowest terms. 7 plus 8 is 15, and the common denominator here is 10. So you can either do one of two things. You can first recognize that the numerator and the denominator have common factors, and you can take those out, and then you can change it to a mixed number, or you could change it to a mixed number, and then you can take out common factors. I prefer to see if I can take out common factors first. So let's do the prime factorization method. 15 is 3 times 5. 10 is 2 times 5. And we see that we can cancel a 5 from both the numerator and the denominator, which leaves us with 3/2. But 3/2 is improper because the numerator is greater than the denominator. So I'm going to take the numerator and divide it by the denominator. 2 goes into 3 one time with a remainder of 1. So this fraction is going to be a mixed number of 1 and 1/2. And that would be my final answer. Now we could get the exact same answer by changing to a mixed number first. So 15 divided by 10. 10 will go into 15, remainder 5. So the first thing I start with is 1 and 5/10. And then I can focus my energy just on this fraction. And this fraction, 5/10, I can use the GCF method to reduce this. I can take the GCF of a 5 out of there. And so my 5 out of the numerator and my GCF 5 out of the denominator. 5 divided by 5 equals 1. 10 divided by 5 is equal to 2. And now I can rewrite this as 1 and 1/2, the same answer I got before. So you see, it doesn't matter if I reduce first and then change to a mixed number, or if I change to a mixed number and then reduce. My preference is the blue one here, where I change to reduce and then change to a mixed number. But sometimes you'll think you have all the common factors out, that you've reduced it, and when you change it to a mixed number, it pops up and it goes, oh, there is a common factor in there. It's just easier to see. So you'll find yourself using both methods. Now, what if I want to add mixed numbers? What do I do then? Well, I have two choices. I can change them both to improper fractions and add just as I was before, or I can add as if the fraction is another place value. So let's see a quick example. So 2 and 1/3. So if I change this to a mixed number, or an improper fraction from the mixed number, remember 2 times 3 plus 1, so 6 plus 1, which is 7/3, plus 5 times 3, which is 15, plus 1, which is 16/3. Now I add my numerators, 16 and 7, which is 23/3. And then I change back to a mixed number. 3 will go into 23 7 times, with 2 left over, and original denominator 3. And so there's my final answer, 7 2/3. Now, I actually prefer just treating the fractions as a place value. And so stacking the fractions over one another and stacking the whole numbers over one another. And I'm just going to treat this like a simple fraction problem of the fraction place value. 1 plus 1 is 2. Common denominator is 3. And 2 plus 3 is 5. And that is our fraction. Now, what happened here? 7 2/3. Oh, I didn't have the same problem over here. This should have been a 5 to be the same exact problem. Sorry about that. So if this were a 5 and not a 3, we would have gotten the exact same answer that we got before. I wanted it to be the same so you would be able to see that, yes, indeed, we get the exact same answers. 2 1/3 plus 5 1/3 is 7 2/3. 2 1/3 plus 5 1/3 is 7 2/3. Now the only problem is if I have the improper fraction concept going on. So if I do this with mixed number or improper fractions, it's not a big deal. It's going to work out quite nicely. It's if I don't have the improper fractions, if I use them as mixed numbers, that I can sometimes get in a little trouble. So I want to show you this one. 3 plus 2 is 5/4. And that is a mixed number, right? That's really 1 1/4. So it's really the 1/4 that belongs there. And then I'm going to carry this up to here. And 1 plus 5 is 6, plus 2 is 8, and 1 plus 0 is 1. So this really looks like 18 1/4. And that's how you would do it if you have to carry. And then of course you could have reducing too. Now you should try it with improper fractions and see that you get the same thing, but I'm out of time.